Welcome to a lesson on practical domain and range. The practical domain of a function is a set of all possible values for the input variable that makes sense in a given situation. And the practical range of a function is a set of all possible values for the output variable that makes sense in a given situation. So the practical domain and practical range deal with application problems. Let's look at an example. The gas station is currently charging $3.83 per gallon for gas. The cost C of N in dollars to fill up your car depends on the number of gallons, N, that you pump. Your car's tank can hold a maximum of 20 gallons of gas. So for part A, we're asked to determine in this situation what is the input variable. Well, we're given the function C of N, so we know the input is N, which should be the number of gallons of gas. So in this situation, the input variable is the number of gallons of gas. For part B, we're asked to determine the practical domain. The practical domain would be, and now because we know the input variable is the number of gallons of gas, the practical domain would be the number of gallons of gas that makes sense in this situation. Well, your car holds a maximum of 20 gallons of gas, so you can't buy more than 20 gallons of gas, but you could buy exactly 20 gallons of gas at the most. Now we want to consider the least amount of gas you could buy. Well, you could buy 0 gallons of gas by not buying any gas at all. And of course, you could buy any amounts of gas between 0 and 20 gallons. And therefore, the practical domain would be N must be less than or equal to 20 and greater than or equal to 0. For part C, we're asked to determine the output variable. The output variable is the cost in dollars. So for part D, we're asked to determine the practical range, which would be the set of all possible values of the output variable, which in this case would be all the possible costs when purchasing the gas. Well, if you purchase 0 gallons of gas, then the cost would be 0. If you purchase 20 gallons of gas, the cost would be 20 times $3.83, which we can see would be $76.60, or just 76.6, which means the practical range would be from 0 to 76.6, including both endpoints. So C of N must be less than or equal to 76.6 and greater than or equal to 0. Before we go, let's look at this graphically. In blue, we see the graph of our cost function C of N equals $3.83 times N, the number of gallons of gas. But for this situation, because the tank holds a maximum of 20 gallons of gas, notice how the possible inputs would be from 0 to 20 gallons of gas. It doesn't make sense to graph our function beyond an input of 20 because the tank has a maximum of 20 gallons. It doesn't make sense to graph the function for values that are less than 0 because we can't have negative gallons of gas. And once we have a restriction on the input, notice how that changes the output. The possible outputs are from $0 all the way up to a full tank of gas, which would cost $76.60. I hope you found this helpful.